Alright, so I'm going to pick up where we left off Monday night on working two metric problems. We worked example 2.8 in class, but I talked about going back over that with you since our quiz is going to be on metric problems. So I'm going to work example 2.8 first, and then I'll work 2.10 a little later on. Alright, so I've got my formulas, and I'll refer back to the formulas in your textbook. So I'm going to be working with these formulas here that are in the textbook. So porosity, we're starting down here with void ratio. This is on page 19 of your new textbook. Void ratio, porosity, degree of saturation, water content, unit weight, dry unit weight, unit mass, dry unit mass, and then their specific gravity. So we're going to start working problem 2.8. Alright, so here's what's given. So they gave us we're given void ratio, which is that little e, is 0.78. And void ratio is actually, so 0.78 is your VV over VS. And then based off my diagram, and of course let me go ahead and put this down. We're given void ratio. We're given specific gravity of the solid for this problem as 2.68, and we're also given water content 12%, but we're gonna have to assume 1 meter cubed. So any problems that I want you to assume that or tell you in a quiz, I will say assume. I'm just not gonna say like the book does and says, okay, we're going to have to assume. I'm going to put in parentheses, assume 1 meter cubed. So if I look at this, VV plus VS has to equal V. So I'm going to write that formula out. V equals VV plus VS. Okay, so right now I can take this equation and solve for VV. So 0.78 VS equals VV. So I know if you want to bring the VS to the other side, you have to multiply both sides from VS and it'll cross out. So you'll be left with 0.78 VS. Okay, so now if we're assuming 1 meter cubed, and now I'm going to plug this right there. So originally we're taking two equations and two unknowns, and we are solving for one sign and then back substituting. So I'm going to say 0.78 VS equals, 0.78 VS plus 1 VS. So now if I solve, so it's 1 meter cubed equals 1.78 VS. I'm going to divide both sides by 1.78. And I'll be left with my VS. And that gives me 0.56, and it would round up to 2 VS. So I can go ahead and plug that back in my, so right now we've got 1 meter cubed. Our VS is 0.56 and it would round up to 2. So the void ratio, or volume of the voids, you can just take 1 minus your 0.562. And VV would be 0.438. Just trying to squeeze it in. Alright, now, so we've got this. I'm going to go ahead and we're going to work on the other side. So with me given, knowing that VS is 0.562, I can solve for the weight of the solid. So I'm going to come down here and plug this in. So if I have the volume of the solid, that is the weight of the solid divided by specific gravity times unit weight of water. So 0.562 equals the weight of the solid, which we don't know. Specific gravity was given, and I believe that was 2.68. And unit weight of water is 9.81 kilonewtons per meter cubed. So okay, so we'll solve for the weight of the solid now. So 0.562, multiply that by your specific gravity times unit weight of water. So the weight of the solid is 14.78 or 775. I'm not going to round it up. Equals the weight of the solid. So I'm going to go ahead and scroll back up and put that in. That is 14.775. Alright, so they gave us water content. So I can work with water content. Alright, so they gave us the water content being 12%, and the water content formula equals, and I'll write it, equation 210. That's W equals WW over WS times 100. Okay, so they gave us 12%. I think this is where I was trying to put an extra step in there, and Paul pointed out, hey, we can go ahead and solve it from straight here, which is exactly right. 12%. Okay, we don't know the weight of the water, but we did solve for the weight of the solid, so I'm going to go ahead and put that in there. 14.775 and times 100. Okay, so I'm going to go ahead and divide both sides by 100. So that'll get me 0.12 equals WW over 14.775. So if I say 0.12 times 14.775, that leaves me with the weight of the water. So I got 1.773 for the weight of the water. I'm going to write 1.773. And then if you'll add the two together, that'll give you your total weight. So 1.773 plus 14.775. So if they tell you the weight is before oven drying or just give you weight, that's the weight it's got your air, your water, and your solid in there. So this should be 16.548. So it's a little different than what the textbook has, because I kept it to 3 decimal places. If I want you to keep it to 3, I'll definitely tell you in the exam, or the quiz, to keep it to 3. If it's in the when we do like a paper exam on this, I can kind of follow your work as long as you show the work. Alright, so now I can go back and solve for the weight, the volume of the water, the volume of the water, because it's just going to be the weight of the water divided by unit weight of water. So since we've got the 1.773, I can go ahead and divide that by your 9.81. And that's going to give me 0.181. And then we can solve for the volume of air because we know the volume of the voids. So if I say 0.438 minus that 0.181, that's leaving me for the volume of the air 2.57. Alright, so I guess we're now ready to do wet unit weight, dry unit weight, degree of saturation, and porosity, because that's what they're wanting to know now. And I guess I really didn't have to know the volume of the air. Alright, so so there's my numbers. Jot them down, and then we're gonna go ahead and solve for what we need. So right now my V is 1 meter cubed, my VA is 0.257, my volume of water is 0.181, volume of voids is 0.438, and I would suggest writing down what you saw for each one so that I can see what numbers you're using when you're dividing if it's around an issue. So my WW is 1.773, my WS is 14.775, and my W is 16.548. Alright, so now we're going to go down and solve for Alright, the first thing that they want to know is what the wet unit weight is. And wet unit weight is using equation 211. Equation 211. And wet unit weight is just the weight divided by the volume. And our weight is 16.548, and that's actually in kilonewtons. And our volume, remember we assumed 1 meter cubed. So that answer is just 16.548 kilonewtons per meter cubed. And that's fine to leave it like that. Alright, so the next one is dry unit weight. So dry unit weight is the next equation down, which is equation equation 212. And looks like that. It's your weight of the solid divided by your volume. And our weight of our solid is 14.775 kilonewtons divided by 1 meter cubed. So dry unit weight is just going to be 14.775 kilonewtons per meter cubed. Alright, so we're getting there. Last two things we need then are degree of saturation and porosity. So degree of saturation, I'm going to do porosity first. So porosity is equation 2.8. And that's going to be VV over V times 100. And our VV was 0.438 divided by 1. These are both meter cubed. So you should, and then forgot to put my times 100 in there. Times 100. To put it in a percentage. That should be 43.8%. Degree of saturation is VW over VV times 100. So our VW was 0.181 and our volume of our voids was 0.438 times 100, and that will give us our S. And I'm getting 41.32%. Alright, so that's the ones that we worked Monday. Here's the solutions in the textbook. I kept mine out a little farther. So as you see, they got for porosity, where they had 40.9 and I had 40.132. And 43.8 versus 44. So that's kind of how we are. We'll pick up with the next video on, and we'll be working example 210.